Hi again, Year 9s. Welcome to your physics lesson. Just a reminder that because this is the lesson straight after your quiz, we'll be going over the answers to that next lesson. So next week, it was my mistake, I should have said next week rather than next lesson. And that gives us time for other groups to also have the quiz. So in the meantime, let's continue with our lessons and your answers to your quiz. Please don't lose your answers to your quiz. You will need them for next week's session on week 5. So for this lesson, we're looking at atomic structure. So in your fact book, you'll need this page on atomic structure. And we'll be looking at the ideas of atoms, how they're made up, what they're made up of, and relative sizes of subatomic particles and properties of those subatomic particles. So, before we go any further, start your lesson. Give yourselves 5 minutes to pause the video and answer these questions. This goes back to quite a few topics back, just a bit of a reminder to make sure that you're not forgetting these equations. Pause the video right now. So these are the answers you should have got. For kinetic energy, it's half mv squared, half times mass times velocity squared. That number 2 hasn't come up properly in velocity, but it should be a superscript, so it should be above the velocity to give a squared figure. So it's velocity squared. Number 2, density is mass divided by volume. Internal energy for number 3 is kinetic energy of the particles plus the potential energy of the particles, which is why when a substance is heated up, its particles gain kinetic energy, so they move faster. That's why internal energy increases. And number 4, gravitational potential energy. This one tends to mess up students sometimes. They forget the difference between gravitational potential energy and gravitational field strength. Gravitational potential energy is due to an object. It's the energy stored due to an object's height, and that's affected by the mass of the object. The field strength of gravity on that planet. Remember, different planets and different bodies in space have different gravitational field strengths. On Earth, our constant gravitational field strength is 9.8 newtons per kilogram. And height, how high up objects held. So, moving on. Structure of an atom. Have a go at drawing what you think an atom looks like. Give yourself 5 minutes, draw an atom, label it the best of your ability without looking at anything. Once you've drawn that, write out how you would describe the properties for each of the different parts, each of the subatomic particles in your atom diagram. Okay, this is a labeled diagram of an atom. Compare yours to what we have here. So, obviously, I don't need you to be artistic. This is just something I whipped up off the internet. So, here we have a representation of an atom. And here we have the 3 subatomic particles labeled. So right at the top we have the electron. You'll notice it's in shells. Electrons have a charge of -1. They are negative. They are so tiny, and their mass is 1/2000. What that means is it's a relative mass. Compared to the mass of protons and neutrons, we would need 2000 electrons to get the same mass as 1 proton or 1 neutron. So it's 1/2000th compared to a neutron, or 1/2000th compared to a proton's mass. Then we have a neutron. Neutron is found in the nucleus, the center part of the atom. Neutrons are neutral. Clues in the name there. That means they're uncharged. They have 0 charge. Neutral. They have a relative mass of 1. Protons, also found in the nucleus, have a positive charge. They cancel out the charge of the electron. Remember, electrons were -1, protons are +1. Protons also have a relative mass of 1. Protons and neutrons in the nucleus, and electrons orbiting around the nucleus in shells. have a go at filling in your table like this. Give yourself a good few minutes based on what we've just gone over in the previous slide. See what you can remember. So this is what you should have got. Proton, charge of +1. Its relative mass is 1. Neutron was neutral, 0 charge, and relative mass of 1. And electrons are negative charge 1. Their relative mass is 1/2000, almost 0. It's so small that you need 2000 electrons to get the same mass as 1 neutron, or the same mass as 1 proton. Right. In an atom, the number of positive protons and the number of negative electrons are the same. They cancel each other out. So if I was to say an atom had 5 protons, you would automatically know that that atom had 5 electrons. They cancel each other out. So the 5 positive charge is cancelled out by the 5 negative charge. And this goes for any atom. However, atoms can lose or gain the electrons from their outer shells. Remember, the electrons orbit the atom in shells. They go around the center of the nucleus, and electrons are the only parts of an atom that can be lost or gained. So that means if we lose or gain an electron, we automatically have an imbalance of protons compared to electrons. The positive and negative charge are now unequal. They can't fully cancel each other out. So we might end up with too many electrons if we've gained, so we've got more negative charge than positive charge. Or if we lose an electron, we'll end up with less negative charge compared to the positive proton charge. So atoms are now charged. We call charged atoms the name ions. So ions are the name for charged atoms which have lost or gained electrons. In your books, can you copy this information down? And any information from previous slides that you'd like to make sure that you've corrected anything that you didn't get right on your atom diagram. Make sure it's absolutely correct. Make sure your table is absolutely correct as well from previous slide. And please get this information down. Now, if you have a periodic table in front of you, if you haven't, it'll be good to Google one right now and have it in front of you, perhaps on your phone. And you'll notice that on the periodic table, we have loads and loads of elements. You've covered this in year 7 and 8. Those elements have symbols. For example, here we've got the element Na, which is sodium. That tells you which element it is. But you'll also notice there are some numbers associated with each element. At the top, in this case, at the top, not necessarily every periodic table has it at the top, but you'll notice one of the numbers is bigger than the other. The massive number, the bigger number, the massive number is called the mass number. That's an easy way to remember it. Mass number is the massive number out of the two. And the mass number tells you in that element how many protons and how many neutrons are inside the nucleus. So in this case, 23 tells you that there are 23 in total protons and neutrons, but it doesn't tell you how many of each you have. It just tells you in total there are 23 protons plus neutrons. However, the smaller number is called the atomic number, and that tells you how many protons out of the 23 there are. So in this case, out of the 23 protons and neutrons in the nucleus, which is the mass number, there are 11 of those as protons. That 11 will only ever be for sodium. If that proton number, atomic number changes, then that element symbol will change because it becomes a different element when the proton number changes, atomic number changes. So to work out the number of neutrons, what would you do? You should have said you take away the atomic number from the mass number to give you the number of neutrons. Because we know 23 is protons plus neutrons, 11 of those are protons, so the remainder must be neutrons. How many electrons do you think sodium has? You should have said sodium has 11 electrons. If you did, brilliant. Because remember, elements on the periodic table are uncharged. The number of positive protons and the number of negative electrons are equal, so they cancel each other out. So if you have 11 positive protons, you must also automatically have 11 negative electrons. In your book, get this information down, please. I'd like you to complete this table, please. I've given you some elements, symbols with some information about mass number and atomic number. I've done the first one for you. Please have a go at the rest of these. Give yourself a good few minutes to have a go at these. This is what you should have got. Please compare these answers to your answers and correct anything that's not right on your paper before we move on. The radius of the atom's nucleus is 10,000 times smaller than the radius of the whole atom. The rest is just empty space. There's no air or anything inside, it's pure empty space. That means that if we were to say shoot up the size of a nucleus to the size of a pea, just a single pea, then the whole atom will be the size of a full-size football pitch. The center part is the nucleus. The outside part is where the electrons would orbit. Everything in between would be empty space. 10,000 times smaller. That number of 10,000 times is very important. It comes up in exams, but it's also good for you to get your head around that a nucleus of an atom is 10,000 times smaller than the rest of the atom. It's amazing. So what's an element? Well, going back to the periodic table, elements are made up of only one type of atom. So for example, if you were to get a lump of gold, every atom in that will be identical to each other. They'll all be gold atoms. They'll all have the same number of protons. But if you were to compare those atoms to, say, a lump of coal, carbon, they'd be different to each other. Different to the gold atom, sorry. But all of the carbon atoms will be the same as each other. Atoms of any element have the same proton number. Different proton numbers tell you it's a different element. So what then is an isotope? Look at those three squares in the middle. They're all carbon. They all have C's. But you'll notice something different about them. We know they're carbon because the atomic number, the number of protons, is 6 in each of them. That doesn't change because it tells us that is carbon. If that were to change, it would be a different element. However, you'll realize the number on top has changed. 12, 13, 14. We know out of those 12, 6 are protons, so 6 must be neutrons. Out of the 13, out of the 13, 6 are protons, so 7 must be neutrons. And out of the 14, 6 are protons, so 8 must be neutrons. So an isotope is the same element, same number of protons, different number of neutrons. We call them isotopes. And they occur throughout the Earth and the universe. This information is very important. This definition is very important. Please copy the information from this slide. So, in this lesson, we've talked about the idea of what an atom is made up of. We understand that we have subatomic particles with different sizes and different charges and different mass. And we also know that most of the atom is empty space. To finish off, have a go at this exam-style question. Answers are coming up. Give yourself a good 10 minutes. And this is the answer. These are the answers you should have got. Please correct any mistakes. In the meantime, have a great week. Your answers to your quiz are coming up in the next lesson next week. So please don't lose your answers. And have a great week. And I will speak to you soon. Take care. Bye-bye.